Hey again, I just wanted to make a really quickie video for you. It was just an AP question that was involved stoichiometry. I'm pretty good with stoichiometry, so here we go. Let's say that it says relating to HCl, CH3Cl and CH3Br. I'm only going to do one part here, A. So it's saying that HCl gas can be prepared by the reaction of concentrated sulfuric acid and sodium chloride, as represented by the equation. Okay. Student claims that this reaction is a redox reaction. Is the student correct? Well, let's look at the reaction and apply some oxidation numbers to see if that's true. So H2SO4 reacts with NaCl. You'll notice I'm not balancing it because redox numbers don't depend on the number of things in the reaction. It just depends on the actual atoms themselves. So and then we get HCl and those are the other things, sodium sulfate, H2SO4. Okay. What redox means is are electrons being transferred? In acid-base reactions, typically no, they're not. It's just a proton. So already you can kind of say that because this involves an acid, there's a good chance that this actually isn't involving redox, but you can show it with oxidation numbers. Oxidation numbers are simply, so we know, for instance, NaCl that has a +1 charge and a -1 charge. HCl is these are really covalent, but you can represent them as ionic. So this is +1 and -1 too. But how does that work for covalent compounds that don't have ions? Well, we can pretend they do. We use a system. So for instance, some numbers are always the same. Oxygen is pretty much always -2. Hydrogen is pretty much +1. Unless it's with the metal, then it's -1. But so well, we have if we're talking about an ion here, sorry, we're talking about a neutral compound here, H2SO4. So these numbers have to add up to 0. So we're saying, well, what is the oxidation number on sulfur? Well, it's going to be 2 times the 1, okay, plus the x, plus, well, 4 times the -2, which is really -8, right? And that all equals 0 because the charge on that is 0. It's neutral. You solve for x, you're going to get +6. All right. Oh, no. No, you're not. You're going to get, no. Yes. Yes, you're going to get +6. Awesome. So sulfur is +6. Okay, now the question is, well, let's look at what happens on the other side. So sulfur is still +1. Sorry, sodium. Oxygen is always -2. If you do the math, it's actually the same. Sulfur is still +6. Is this a redox reaction? The question is, do the oxidation numbers change between the reactants and products? The answer is no. Sodium is +1 to +1, no change. Hydrogen is +1 and it was +1 before. Sulfur is even +6 and +6. So notice because there's no actual electrons involved in swapping, there is no redox reaction. So this is not a redox reaction. So you can say that because it's an acid base, or you can say because, well, you can actually prove it with the oxidation numbers. All right. What about the stoichiometry? It says calculate the mass in grams of NaCl needed to react. So NaCl needed to react with a known excess of H2SO4 to produce 3 grams of HCl. Okay, guess I didn't need to write that, it's redundant. So notice it says this is an excess. What that means is that there is enough of this chemical to fully react with the NaCl. So therefore, we don't really care about how much H2SO4 is needed. The whole point is that enough is used to completely react up NaCl. Makes the calculation more simple. So we don't actually have two values and have to find out which one is limiting, which one is excess. So they tell us. So notice it says, well, we need to find the mass in grams of NaCl needed to react with H2SO4 to produce enough 3 grams of HCl. So you always really want to start with what you have and work your way to what you don't have. So notice what's balanced first, because you need an equation when you're doing stoichiometry, and you need to balance. I think we've covered, yeah, okay, we're good now. So here's the main story we're telling. We're telling the story of, on the molecular realm, how are these reacting? What's the ratios? So remember, these go by moles. So this is like saying 1 mole of H2SO4 reacts with 2 moles of NaCl. Then you're going to produce 2 moles of HCl, and then you're going to produce 1 mole of Na2SO4. So the main event is, how are these related by their mole ratios? And then once we take grams on a human scale, a laboratory scale, then we can say, well, maybe we start with grams. Let's go to the molecular scale, moles, see how they react, and then find grams of something else. So your main event is your mole ratio. And so we need to find the mole ratio between HCl and NaCl specifically. Notice it's a really a 1-to-1 because they're both 2. So remember, this is excess. We don't care about that. We're just looking between HCl and NaCl. So in other words, we're saying that there's an equivalent quantity here. 2 moles of NaCl in the reaction are reacting equivalently in the same scale with HCl. Guess what? That's a conversion factor, because we have 2 things equivalent to each other. So we can say 2 moles of NaCl over 2 moles of HCl. And you're like, well, what's the point of writing 2? It simplifies to 1. It's good practice. It's not always going to do that. Sometimes you have big coefficients. Well, but we start with grams of HCl, right? So how can we convert moles to grams? Well, you can actually say, well, if there's 3 grams of HCl, what's the relationship between moles and grams? Well, we know that for every 1 mole of HCl on the periodic table, you could add up the individual molar masses of hydrogen and chlorine. And I think it's let's see, so HCl, that's going to be, so hydrogen's about 1, chlorine's about 35. So let's call it 36, just for simplification here. Obviously, you probably don't round it so heavily on your test. And then check this out. The grams of HCl cancels. We know the moles of it, and we know how it reacts in mole ratio with NaCl, which is what we're looking for. So that cancels. And well, now we know how many moles of NaCl are created, used up. And notice you don't always have to. You're used to these ones where they give you reactants and they say to find the products. You can go back and forth. You can go anywhere you want. You can go between reactants too, because they're all related to each other with their coefficients. So we're going specifically between HCl and NaCl. So remember, the main event is the mole ratio, and we're just saying, well, we start with grams, so we need to go from grams to moles to see that ratio. So this is the main event. These are kind of the fringe work to get to the main event. So now we're gonna say, hey, we know what the moles of NaCl is. How do we actually calculate the grams of NaCl? Molar mass, right? So for every 1 mole of NaCl, we are going to produce, sorry, that is equivalent to some grams of NaCl. If you add it up, Na is like 23, CL is 35, so is that like a 51-ish? I can't do math well. Usually you do the whole decimals just to be specific, but so Na is about 23, and then what was chlorine's 30, we'll call it 35, so 58. Sorry, I'm just suck at math right now. So not even had to add it up. So 58 grams of NaCl. The moles cancel, okay? And we're actually going to get our thing that we actually need. So you do the math and let's see here. All right, so we're gonna do 3 times 2 times 58 divided by 36 divided by 2. You can multiply top across, you can multiply across the top and then across the bottom divide, or you can do what I did sequentially. I'll show you one more time. You could do 3 times the 2 on top times 58. Then you can divide sequentially by 30 to 36. Then do it again by 2. There, 4.8 sig figs. Remember, you can't use sig figs from these equivalent quantities. These are known values. Typically, honestly, the sig figs can determine based on your periodic table. So go with your given amount, which was 3.00. That's 4 sig figs. 3.48 grams of NaCl are created. Boom. Okay, that's all I really wanted to show you. And good luck out there, okay? Best of luck.